Stick to whatever the college says the final exam schedule is.
I have a class that starts at 12:15.
All right, so
We're starting that one earlier time. So
let's take a peek at that. Oops. Interesting. All right, so on the schedule, I wrote, oh, it's 8 o'clock.
yeah.
Monday, December 5th at 8 a.m. Woo!
Okay.
Hi, Daisy.
Hello.
Oh, muted. Let's unmute you. Okay, there we go. Let's double check that with the college schedule, make sure I got it right. Oops, wrong button.
So that's Tuesday.
Oh, that's got the wrong. Okay, so I have a day and a date that don't match. Let's see what the college says. Academic calendars.
There's a Monday, Wednesday.
Oh yeah, the 4th is a Monday, isn't it? Yep. Okay, let's see. Final exam schedules. We meet Monday, Tuesday, Wednesday, Thursday at 10. It's supposed to be Monday at 8. So I had the right day, wrong dates. Let me fix that quick. Yeah, Monday at 8. It is the 4th. And then we go from the calendar, just double check that. Kristen, you have the worksheet 4, right? Okay.
I think on Tuesday, because I actually coming for one fun on Tuesday.
Wrong class. We have Quant Lit. Is that the right Quant Lit? Oh, we got all this extra stuff. What is this? Oh, that doesn't go here. Let's see.
Dealing fast.
I know it is.
That goes here. One of those is going to go. Okay. So I fixed that.
What time Christmas break came on ready,
All right, so we were playing with population density last time. Let's continue where we left off. Get my notebook up. He keeps going for the next couple of sections.
So how far are we trying to do?
What's that?
How many lessons are there into?
There's 10 in this module, so we're going to try and do all 10. We might not get to number 10 because we're a couple days behind, and that's okay if we don't get there. All right. All right, I'm gonna get my spreadsheet for the calculator, and then we'll get moving. Spreadsheet.
I have a problem with conversions.
Okay.
100 foot by 100 foot.
Wow. All right. We'll take a look at that again.
Or I guess what we're at.
Oops. Let's see, did I start one last time? Doesn't look like it. All right, so which number was that?
4.
4. All right, 1 million people standing in his or own 100. Okay, so we did the 2 by 2 square foot one, right? Now we're moving on to 100 foot by 100 foot square, and we want to change that into density per square mile. So just similar thing to consider last time. We don't have 1 million people standing in a 100 foot by 100 foot area, but each of 1 million people has their own 100 foot by 100 foot area. So the density there is 1 person per 100 by 100. So that's going to be feet squared or square feet. So that's what we're starting with. So we can clean that up a little bit. That's 1 over 10,000. 4 zeros, people per square foot. And usually populations, people per square mile, when they talk about population density, so we need to convert this. So the trick on that, and we messed this up a couple times last time, but we'll get it right today, is we know that there's 5,280 feet in 1 mile. We need to change that into square miles, which means we need to square both sides here. And that'll change us from linear measurements to square measurements. So we gotta whip out our calculators and figure out what 5,280 squared is. So, my calculator, so I've got miles versus feet. 5,280. It's going to be a really big number. Oops, I put that in the wrong order. 5,280 versus 1. And I'm going to go for square miles, square feet. Yeah, big number. So every 1 square mile, put some commas in there. Yeah, 28 million. It's a lot. 27,874.
There's 28,100 by 100 square feet.
So in 1 square mile, there's 27,878,400 square feet. Yep. Square mile is a big area, right?
Yeah.
So there's going to be a lot of little tiny square feet in there. So to do the conversion here, we need to get rid of square feet. So we're going to have to multiply by this number. Because we're going to take our 1 over 10,000 people per square foot. We want to get rid of square feet, so we're going to have to multiply by the 27,878,400 square feet to convert to 1 square mile. So that means we're going to have to, multiplying across the numerator, we're going to have the 27 million in the top, we're going to have the 10 million in the bottom. And so we're going to have to divide the 10,000 in the bottom. We're going to have to divide the 27 million by the 10,000. So in terms of, people per square foot versus people per square mile. Here we've got 1 divided by 10,000, right? Here we're going to have to multiply that. Oops. Times that 27 million. So we get about almost 3,000 people per square mile, if we break that up.
What do you mean?
So that's this calculation right here. So take your 1 over 10,000 and multiply it by 27,878,400. So that gives us about, so we said in here, 2,787. We'll go, it's 0.84 technically, and that's people per square mile at that point. So if one person gets 100 by 100 square for their own, and inside of a square mile, there would be almost 3,000 people. How much space does each person have in that square mile? Each of those 3,000 people has about how much space? What's that? 10,000 square feet. Yeah, they have 100 by 100 square, which is 10,000 square feet in there. Okay, so like those floor tiles out in the hallway, 100 by 100 square, has 10,000 of those in it. One person has that in a mile, that'd be almost 3,000 people. That's what we just calculated. No, we take this number divided by 10,000.
Yeah.
And that gives us 2,787 roughly. We round up 2,788. So here's what we calculated. If we start off with one person in every 100 foot by 100 foot square, then inside 1 square mile, there's going to be about 2,788 people if we round to the next whole person. Those two numbers mean exactly the same thing.
Which is actually, well, could be considered a city lot, 100 by 100. It would be actually a big city lot, wouldn't it?
Yeah, like in my neighborhood, I think most of on each corner, there's a 100 by 100 lot, and then all the ones in the middle are 100 by 50.
Yeah.
So so that's like a quarter of my neighborhood has this much space. The rest of us had half that. Yeah. So just imagine now. Let's tweak this just a little bit. Suppose different density. We got to cram more people in Pendleton, so all new lots are going to have to be 50 by 100. Now, there's going to be more than one people in a lot, but let's just put one person in each lot. What's that going to translate to for the number of people in a square mile? So take a guess at it and then try and make a calculation. So I just took this lot, I cut it in half. What's the result going to be for the number of people per square mile? Just make a guess at it and then try a calculation, and then we'll see if we come up with the same number. So my guess is each person takes up less space, so we should be able to fit more people in a square mile. So I'm thinking it's going to be more like 5,000-ish. Okay, so I'm just going to make that calculation to double check on the next page. So I'm starting off with a density of one person, and then I have 50 times 100. So that'd be 5,000 square feet per person. I want to change that to square miles. So I have to multiply by square feet. And we calculated there's 27,878,400 square feet in every square mile. Fraction, multiply across the numerator, multiply across the denominator. So ultimately, I have to take my 27,878,400 and divide it by 5,000. And whatever that is people per square mile. And my guess was it's going to be a little over 5,000. Hang on, what was it called?
5,575.68.
575.6. So let's call it a 576 then.
Yeah.
We round to the nearest person per 1 square mile. Yeah, so we force each person to have less space. That means there's more people in the bigger square mile. More people in a square mile means less elbow room, right? Which is what we did. We downsized everybody. Yeah, and it seems astounding. Okay, we get that. There's 5,280 feet in a mile, but the key is, you know, here's a mile. There's a lot of feet in a mile, right? So then you make it a square mile, and you get a lot of feet going this way. So when you make that grid, there's a ton of little squares here, right? Oops. Trouble spelling today, as usual. So how many little squares are there in a 1 mile by 1 mile section? How many floor tiles do we need to make 1 square mile? 27,878,400 of those little tiny square feet make up 1 square mile. Right, it's a huge number. It's hard to wrap our minds around, but that's the way it is. All right, so we got number 4 nailed. So what I want you to do now is take a look at number 5. Start reading through that, give it a shot and check with your neighbor. And then we'll regroup and double check with each other. For 5. So we're going to try and compare China to the US in terms of population density. So write something down, make an estimation, and do a calculation. So at first, we're just going to estimate it. Who is more dense, China or the US, based on the figures above? So is China land-wise much bigger than the US? They're pretty darn close, aren't they? Who has more people? So who is more dense? Okay, so the student in part A says, no, I think China's less dense. Do they have any grounds for that? No, they made a mistake somewhere. In the second part, somebody claims that China's 4 times more dense. You'd say true on that?
That's true because it's almost 4 times as many people.
Yeah, if we take 4 times 3, that would be 12. Over here, we essentially have a 13. So yeah, there's more than 4 times as many people in China in about the same land space. So it seems reasonable that China's about 4 times more dense. They have 4 times as many people crammed into any region as we do, on average. Yeah. All right, make those calculations, write something down. Neither do they. All right, so these are the numbers I get. I'll talk about those bottom numbers. So I get US has about 83 people per square mile on average. China has about 360 people per square mile on average. People divided by area for each one, people divided by area. So just take the number of people in China, 13 million, and 1 billion, 300 million, divide by the 300,000 square miles. Sorry, 3 million square miles, and put commas in here. Read them. Do those divisions. Now take your 309 divided by 51. Let's go down to the spot. Yeah, so for the first two parts, we're just guessing. For me to help guess, it helped that I wrote down these fractions so I could see what they looked like. Now, I don't know what they come out to yet, but I can see the denominators are pretty close, but the numerators, China's got way more people, even though it has about the same area as the US. Oops. So just estimating, I think that person is wrong, and writing down those fractions is one way to talk about it. For part B, we can see that China has about 4 times as many people in the same area. So that seems like a reasonable claim. Part C, we actually make the calculation. So this is my answer for part C here. Questions on those calculations? All right, so I'll give you guys a few more minutes to write stuff down. And we'll try to figure out the next question. You already got the next one? All right, Cole claims they're both right. We'll catch up to you in just a minute. All right. Next question. So there's a couple of statements here. Anchorage has has more than 40% of the Alaskan population. And Ketchikan is the most dense population in the state of Alaska. Can they both be true?
Yes.
Okay, why? Yes. How come?
Anchorage should cover a large area with a large amount of people.
Okay, Anchorage today, I could have a large area with a large amount of people. And Ketchikan? Yeah. Anyone ever been to Ketchikan? No. It's this little tiny spot right on the water, and they're surrounded by mountains, and they don't have a lot of space. There's a lot of people crammed in that little area. A lot of people with respect to that little area, but Anchorage has more space, yeah. So it's totally possible this can happen. So this is working us up to the next unit, which is, we're still playing around with population densities, but like we compare US to China, we're gonna try and do more comparisons. So back to my spreadsheet for a second. I calculated some extra numbers at the bottom. So there was that 5B talked about someone claimed that China was 4 times more dense. So to calculate that, I took China's population here and divided it. I divided China's population density by the US population density. So I wanted to see how many times 83 went into 360. And it goes in a little over 4 times, 4 1/3 times. I reversed the calculation over here. So here I took the US population density and divided by the China density. Right? So I'm looking at it in the other direction. So this one says China's 4 times more dense. What does the 0.23 mean? Yeah, you could say it's a percent. So how would you phrase it then with the 23%? Well, we would say the US has 23% of China's population density. We couldn't say we're 23% less dense because less means we did a subtraction. So how much lower is 23% than 100%? So consider that a percentage for a minute. About 70, 75%. So what we could say is the US is about 75% less dense than China. And that's taken away from 100% given that China's our measuring stick. So China would be 100%. Okay. So it's usually, when you do one of those divisions, it's a whole number, it's usually pretty easy to interpret. But when it's a fraction, like 23%, 0.23 is a little harder to interpret. And that's what we're going to be working on next, how to interpret those differences. Okay. All right. I think, did somebody say they had a question on the homework in 2-4? Emily said she looked at it in the card. I'm going to pick on one of those questions right now. So if you haven't looked at it yet, don't worry about it. You can look at it tonight or tomorrow, sometime soon. But I've got a question here we're going to take a look at together. So I decided to pick on that Anchorage, Alaska question a little bit by getting some numbers here. So I went online and I go to Wikipedia a lot for data. It's usually pretty right on about things like this. So Wikipedia states that the city constitutes more than 40% of the state's total population. Okay. And if you click on that one there, it'll take you to the page where I found that information. So what we want to do is calculate the population density for Anchorage. In 2010, there were 291,826 people living in Anchorage, and they had almost 2,000 square miles. So whip out a calculator, help me out with this. What would their population density be? I can't blow that up anymore, I still see it. So we have 291,826 people divided by 1,961.1 square miles. What do we get when we whip that out for a population density? 138.8? Let's see, and this says round to the nearest person per square mile. To the nearest whole person? 149? Everyone else all right with that? Okay. So then I also checked out Ketchikan. So Ketchikan didn't have a lot of people. They had 7,368 people, but they only had about 4 square miles. This little tiny place that they live in. Right, so what's 7,368 divided by 4.1? 1797. Oh my gosh, not a lot of elbow room in Ketchikan. People are crammed in there. Could we figure out how much square feet each person has? Let's check it out. So I'm going to snip that into a new screen. Ketchikan. All right, magic marker, where'd you go? So we have 7,368 people taking up 4.1 square miles. Now we just approximated that. What was it again? 1,000 what? 97 people per square mile. What I want to do is convert this, and we'll play around with it a couple different ways. I want to get rid of square miles. I want to change to square feet. So I know that 1 square mile, and hopefully you guys wrote this down in case I get it wrong, is 27,878,400 square feet. Does that sound right? Anybody write that down? That's right? Okay. Yeah, so to make this calculation here, ultimately we have the 1,797 divided by the 27 million there. Okay, now that's going to be a weird looking number when we first calculate it, so let's whip it out anyway. So I'm going to go to my Google screen, open up a new sheet. Actually, I'm just going to go to regular calculator. 1,797 divided by 27,878,400, and I get this wicked little number. Okay, so what does that mean? 1, 2, 3, 4. Let's put a 6. That's people per square feet.
Not even a whole person.
Not even, yeah, somebody's big toe gets a square foot. So we got to do something about that because it's not quite working out. We need some whole numbers to talk about people. So did I get the number of places right? Was it 1, 2, 3, 4 zeros and a 6? You may have that in front of them. Aaron, yes? Okay. So I'd like this to be a whole number. So I think what I'd like to do is shift this decimal point 1, 2, 3, 4, 5 places. So I have to do the same thing in the bottom. In the bottom, there's essentially a 1. Decimal point's here, so I'm going to have to add a 0 for every place I move. So I could rewrite this as 6 divided by a 1 with 5 zeros. So that means there's 6 people for every 100,000 square feet. Doesn't seem so bad. 1,700 people packed into a square mile. Does that sound like it's pretty crowded at first glance? Compared to Ketchikan, not Ketchikan, what's the other one? Anchorage. Compared to Anchorage, it sounds pretty crowded. But when we break it down into square feet, 100,000 square feet, is that bigger than a 100 by 100 square lot? Yeah, that's a pretty big square lot, 6 people in each one of those. It's not too bad. Okay. Right, so there's different ways we can look at it to try and wrap our minds around it. When people generally talk about population density, they're usually talking about cities, they're talking about towns, or countries or states. They always talk about people per square mile. But sometimes, I can only wrap my mind around it if I change it to square feet and think about places I live. Okay, so we are going to finish early today with one catch. The catch being, you guys go do some homework today, catch up on stuff you haven't done. Super important for tomorrow. Prep for 5. I'm going to zoom out on this just a little bit. Oops, too far. The prep for 5, question number 5. This one's got to be done for us to do worksheet 5. If everyone doesn't do this for tomorrow, then we won't have the data we need to complete worksheet 5. So we're pretty much done with worksheet 4. We got down to the last question together. You got to tidy up any homework or prep you haven't done. Please, tonight or before class tomorrow, at least do question number 5 and prep for 2-5 so that we can do the work, get the worksheet started together tomorrow. All right? Thank you. Have a good day.
Professor,
What's up, Daisy?
for lesson 2.3,
Yeah.
I tried to upload it,
Oh, the box
but
is
it
missing.
says text only.
Okay. I could have sworn I hit the button there. Yes, you have 2.4. You can just drop it up here. Sorry, Daisy. Let me take a look at that. 2. Which one? 3?
Yeah.
Okay. This one here. I forgot to put the file up here. All right. There you go. I'll go double check the others now.
Thank you.
You're welcome.